All right, so we are looking today at the truth tables for validity in propositional arguments project. And what we're looking at here is essentially after you finish your definitions here for the truth functional connectives, right, and what they represent. And I also recommended that you write in this section here what words represent these symbols, right? Also, on the right-hand side, you're going to determine how to read the truth value, right? So if it's, for example, a conjunction, that means that both of the variables have to be there, right? Both propositions have to be there before it can be true. If only one is missing, or if only one is there and one is missing, right, that is a false conjunction. That's an example of what you would put here and how to determine its value. Now, I wanted to look at the sample argument first so that we can combine the rules that we learned for reading the validity of a propositional argument with the formatting that you learned about using Microsoft Word to create tables. So before we actually start creating the table here, we're going to do a little bit of reading of our argument here. So we've got P and Q, therefore P or Q. So I want to remind you that this is indeed a symbolic form of a written argument. And what we did is we were able to take that first premise, whatever it was, and recognize that it was indeed a conjunction, right? That's what this little dot here means. So it's P and Q, whatever P and Q stands for. Therefore, P or Q, right? Whatever P or Q stands for, and it's going to stand for the same thing because we're talking about the same argument. All right, so as we're looking at our rules here, the first thing that we're going to determine is how many atomic propositions do we have, right? Another way of thinking about that is how many variables do I have? Well, I've got P in number one here in the first premise. Okay, there's one, and I've got Q, there's two. Then I go into the conclusion, I've got a P, but I've already counted that. And then I've got a Q, but I've already counted that one. So we have a total of 2 atomic propositions. All right, so what do I do with that number 2? We know that for the rows, we're going to use that 2 to the power of n feature or function. We're going to replace the number n with the number 2. Why 2? Because that's the number of atomic propositions that I have. So if I replace the 2 to the power of n here, it means that I'm going to take 2 and multiply it times itself, right? So 2 times 2 is 4. So I'm going to have 4 rows to record all the possible scenarios for P and Q. But remember, we add one additional row because we need a header row, right, to describe what it is that we're going to be measuring for. So in total, 4 plus 1 is going to be 5, right? So we're going to have 5 total rows. So I'm going to write that there to remind myself of what I'm doing. Then I'm going to look at the columns, the ones that go up and down. All right, so how many columns do I need? Well, I need one to record all of the atomic propositions and all of the complex propositions, which essentially means the parts of the argument. All right, so we already figured out that we've only got 2 atomic propositions, right? 2 variables. Okay, so I've got 2 columns for the P, actually 1 column for the P, 1 column for the Q. And then I need to have a place for the complex propositions. What does that mean? I need to have a place for P and Q. All right, so that's 3 columns, and another place for P or Q. So that's 4 columns. All right, so I've got 4 total columns that I'm going to be working with here. So now I know that for my table, I'm going to need a 5-row, 4-column table, right? Or 4-column, 5-row table, whichever way you want to think about that. All right, let's go ahead and start creating our table. So that as we're looking at Word here, this is Microsoft Word, we see all the ribbons at the top here. And in your training, you looked at specifically the ribbons or the tabs that deal with the things that we're working on for this project. Whenever you want to add an element to your page, you go to the Insert tab. Insert has the features and the objects and the shapes and all kinds of things that you're going to be able to insert literally onto your page here. We're going to look for insert, and then we're going to look for the tables group. Here's table. I click on that drop down arrow. And as you saw in your training, there's lots of different ways that you could select your table here. So we know that we want 4 columns and we want 5 rows, 2, 3, 4, 5. We could do that, right? And as you see on the screen, it already starts putting in the table there. Or we could use this insert table feature. Now, as you probably noticed when I was going onto the screen here, it looks like my insertion point is not in the right place. All that means is that I have to click out here, right, in this white area to show or to put my insertion point so it doesn't compete with this other text here. All right, so now that I've got it in the right spot, I'm going to go back into table. And the second way that you could insert a table, and for this particular project, I like this way better. If I click on insert table, then I can specifically type in the number of columns and number of rows that I need, right? And I've already done the work for that. Remember how many rows do I need? I need 5 rows. So I'm going to go in here and type in 5. How many columns do I need? Well, I need 4. You can also use your spin arrow, right, to get to the number that you want. But this allows you to have 4 columns and 5 rows. All right, so that looks good. But there's one more thing that I want you to look at here. I am going to show you here how, as you're creating your table, you can click on Auto Fit to Contents. So the table is only as big or as little as you need it to be. So there's not a lot of extra space. Now, I want to show you what that looks like first, right? So that you can see how small it looks like at first. And then I'll show you another example, if you don't do the auto fit, what that looks like as well. But auto fit is one of the features that you will be employing for your tables here. So I clicked on auto fit and I click on OK. And there's my tiny little 4-column, 5-row table. Okay, now it's auto fit, which means it only gets as big or as little as I need it to be. So now I'm going to put in the values that I need. So the first thing that I'm going to write right in my header row here is I'm going to include a spot for all of the P's and all of the Q's, right? So I'm going to make sure that my caps lock is on, and I'm going to type in the P, and then I'll use my arrow key to get to the next column, and I'll type in my Q, and then I'll get to the next column, and now I'm going to type in my actual parts of the argument, right? So P and Q, and then in the next column I'll write P or Q. So here's my P. Oh, but now I have to put in a symbol, right? Why a symbol? Because the and, or the conjunction, for us is represented by this little dot. Now, another part of the lesson that you learned about for Word was for inserting symbols. So I'm going to go back into Insert, and I'm going to go over here all the way on the right-hand side to the Symbols group. And you saw here in the Symbols group the drop-down arrow. Now, once you use any of these symbols one time in this project, then you'll have them available to use again, right? But let's assume that you haven't put the symbol for the conjunction into your symbols yet. So if you click on More Symbols, it takes you here to the default font, which is the normal text. Now, I gave you a shortcut sheet here that allowed you to see what you would type in to get to a specific symbol here. So one of these symbols for conjunction, or one of the shortcut options, was 2022. When I type in this character code, it takes me to, in this specific font, that special character, because each character has its own code, right? So if that's satisfactory to me, if that's a conjunction symbol, and it is, I'm going to go ahead and click on Insert. And what it does is, once I click on Insert, I'm going to go ahead and close it because I clicked on it once already. And then I close it, and you'll notice that there is my beautiful little conjunction dot, right? Okay, so I've got my P and I've got my, now I'm going to type in my V. Okay, now I'm going to go forward to the next column by using my arrow key. And I'm going to type in the conclusion, because we remember that the conclusion always goes in that last column. Type in the P, and then the small v, and the capital Q there. All right, so far so good. And what you probably noticed is that as I was typing these characters here, my column got a little wider to accommodate each part of the characters, right? That's autofit, and that's what I want you to employ as you are working on these. Okay, so now let's go ahead and look at our actual rules for filling in these values here. Now, the P and the Q are the atomic propositions. For the atomic propositions, we use the pattern of half, right? That's what we called it there. Now, I want to remind myself that I am going to just do pattern of half here for the P and Q. And I'm going to remind myself by using a very thick border that's going to divide the P and the Q from the rest of the table, right? The actual arguments. Now, how do we create that border? So again, this is part of your training. But one of the things that I want you to notice is that when you actually click inside the table, you get a new tab or a new ribbon, right, that you didn't see there before. Look up here where it says Table Design and Layout, right? It's there now, but what happens if I click outside the window? Let's say I click over here where the text is. Oh no, it's gone. Well, that's because the Table Design tab or ribbon is only available when you're actually in the object that you're working in. I click on the table again, and here it is again, right? And the Table Design and the Table Layout tabs have everything that you need to make any changes to the tables, right? They've all been put into this very neat sort of place that allows you to see everything you need, again, to make changes to your table. So what I want to do is actually part of my table design option, because it's a border, a very thick border. So probably the simplest way to do this, and you can play around with this if you'd like to be a little creative here, but what I think is the simplest way to do this is to go into the width or the line weight of your border and click on the drop down menu, right? Whenever you see a little arrow here, it means open me up because I've got more to show you. Click on that drop down arrow, and I'm going to choose a nice thick border, a 3-point border. And notice what happens when I do that, right? Because I've chosen a design element for my table, now I've got this sort of cool looking pen on my screen, right? And that visually tells me that now I can apply some sort of design feature to any of the borders of this table. Now I want to separate my P and my Q from the rest of my argument, right? So the most logical place to separate that is on this line right here. So how do I apply my border? I click, right? I click right over the line and I don't let go, and I keep drawing that line all the way down, and then I release it, and you'll notice that I just applied my nice thick border. Now, if you happen to make a mistake as you were applying the border, remember the keyboard shortcut for undo is Control-Z, right? It's one of my favorite best friends because it allows me to correct the mistake that I just previously made, and then you can start the border again. But in this case, I didn't make a mistake. I was able to apply my border. But notice that even when I applied my border, I still have it turned on here, right? See how it's still activated? So I'm going to use, there's actually two methods that you can use to take off the border. One of them is to toggle off the border painter, or we can also use the universal sort of shortcut for getting out of the feature that you've activated, and that's the escape key, which is at the top left of your keyboard. So if I press escape, notice that it goes toggled off, right? So it's no longer there. And my insertion point looks nice and normal. Okay, so I've got my nice separation here. Let's go ahead and go into our actual rules for determining the patterns here. So the pattern of half, I started off with 4 rows. That's my starting point, right? 2 to the power of n, it gave me 4. I know it says 5 here, but we know that that extra row is just for the header. It's actually 4. What's half of 4? You got it, it's 2. So I'm going to put in 2 values for one of the truth functions, right? One of the truths, and 2 true values for the rest, right? But we remember that there's only 2 truth values available to us. It's either true or false. So I usually start off with the true because it's just easier to do, right? So I'm just going to go 2 trues and 2 false. Okay, got it. Now I went from 4 rows to 2 trues, 2 falses. Now I'm in the Q column. The pattern I just used was 2 trues and 2 falses, right? What's half of 2? Yep, 1. So what am I going to do? Well, I'm going to still start off with the true. I'll put in 1 true and 1 false. I still have remaining values, so I'll keep going. 1 true and 1 false, right? So in the P and Q, all I did was write in my values based on the pattern of half. I didn't have to analyze a thing. All I had to use was the pattern that has been established for me because it works, right? It allows me to calculate for all the possible scenarios in which these premises are true or false, right? I didn't have to analyze it. Now, I go to the right of my nice heavy border, and each of you should have this nice heavy border on each one of your arguments. Okay, and why do I have the heavy border? Because now it's a reminder that whereas in the first half of my table, I was just writing in patterns, in the second half, now I have to analyze. I have to understand what each one of these truth functional connectives looks like and what it means, right? And I have to be able to sketch out how I'm going to interpret it, right? So I can analyze my true or false value. Now this is P and V, it's a conjunction, right? It means that both of those have to be there in order for this value to be true. Now, how do I know whether or not they're there? We're going to look here in that first row, right? That was the point of doing all these possible scenarios. Now I can see in the first row, do I have both P and Q? Yeah, I do, right? I have both a P and a T here, Q here. So it's true that they are both indeed there. Okay. In the second row, do I have the P? Well, yeah, I do have a P. Do I have a Q? Oh, no, I don't have a Q, but I did have the P, right? Are they both there? Because that's what a conjunction means. No, they're not. So in this case, in row 2, P and V are not both there. So it's a false value. All right, let's look at the third row. I've got F. Oh, right there. I don't have the P, right? The P is not there. I've got a false value for P right in the first column there. So if the first one's not there, then we know that they're not going to both be there, right? So right there, we can see that they are not both here. P is missing. Q is there, but P is missing. So we're going to write in a false value here. Okay. How about the fourth one? Are they both there? Well, as it turns out, neither one of them is there, right? So in this case, we're going to have a false value. All right, so we were able to read, right, this argument here. We were able to evaluate whether or not it was a true or false a value that we were going to write in based on the patterned sort of scenarios there. All right, let's keep going. Now we've got the P or Q. This is a disjunction, right? It means that only one of them has to be there. I can have a P or I can have a Q, right? Or if you want to think about it reversely, I can have a Q or I could have a P, right? As long as one of them is there, it's going to be a true value. Now, it doesn't matter, guys and gals, which one it is, or if it's both, right? As long as one of them is there, it's going to be a true value. The only time it's going to be false, right, is if neither one of them is there. All right, well, let's see what we're looking at here. P or Q. Is it true that P or Q are there? Well, yep, I've got a P and I've got a Q. They're both there. Does it matter if they're both there? Nope, not in this case. Only one of them had to be there, right? And they are both there, so one of them is there. Okay, so let's look at the second row here. It's true that I have a P, but I don't have a Q in this case. Do I have a P or Q? I do, because the P is there, but the Q is not. Doesn't matter because the P showed up. So we're going to make that a true value. All right, how about in the third row here? Looking at the oh no, oh gosh, I don't have a P there, right? But I do have a Q. Do I have a P or Q? Right, even though the P is not there, the Q is, so I do indeed have a P or Q. In this case, it happens to be the Q, so this is true. Either P or Q are there. Then we look at the last row, and it says that we've got, well, P didn't show up in that one. Okay, how about Q? It's not there either, right? So do I have a P or Q in this case? In this case, I do not. I have neither the P nor the Q, right? So in this case, I really do have a false value. Okay, now that I've filled in, right, my values based on my patterned values here in the first half of the table, now I'm going to look for validity, right? So we do all this beautiful work, and we do this because we want to make sure that we understand whether or not this is a valid or not argument, right? And sometimes it's more difficult to determine that based on our own background knowledge. So we use our truth table tool. The next step then is going to be to look at our values here. So remember the definition of validity, right? What's the definition of validity? Say it to yourself, right? If an argument is valid, if the premises, an argument is valid, when the premises are true, right? And that leads to a true conclusion. If the premises are true, guys and gals, the conclusion must be true, right? Now, if you look at that conversely, if the premises are true, but the conclusion is false, then you have found an instance that proves that argument to be invalid, right? So if you have true premises, you should have a true conclusion. But if you have all true premises that lead to a false conclusion, that's when, again, you have found an instance of invalidity. So what are we looking at here? Okay, I've got in my conclusion, right? So the next part of this reading of the validity is going to have us focus on our conclusion here. in my conclusion column, I'm going to see, well, you tell me, should I look at the truths? Well, no, we're not going to look at the true values in the conclusion because remember, in order to find invalid statements, we're looking for all true premises that lead to a false conclusion, right? So in essence, we're looking for that false conclusion. All we need to do is to prove whether or not this is invalid. If we can't find any evidence to show that this is invalid, then it becomes a valid argument. So I'm looking for, in the conclusion column here, the false conclusions only, right? I've got three, in this case, three true conclusions, but I care most about the false conclusion. Why? Because I want to see in this false conclusion row, was it preceded by, in front of it, did it have all true premises that led to that false conclusion? Well, let's see. I've got my false conclusion here. Is it preceded by a true premise? Well, no, look at that. It's not, right? In the case of our table here, it looks like a false premise led to a false conclusion. You're thinking to yourself probably, well, that should be false, right? That should be invalid. Well, but that's not the definition of invalidity. So in order to claim an argument is invalid, remember that you have to have a true premise that leads to a false conclusion because that's the opposite of the definition of validity. Now, in this case, I don't have any instances where I have true premises that lead to a false conclusion, right? That means I did not find any evidence of this being an invalid argument. Therefore, I would declare that this is a valid argument, right? Now, in this case, guys and gals, we looked at each part of our rules, right, as we were building our table here. So it's always important for you to make sure that you understand how to determine the truth values, right? Because you're going to be applying them as you're going through your arguments here. Okay, take a moment to write down or to recreate the table, right? Make sure that you understand how it is that we recreated that. And I'll come back in a little bit and we're going to do another one of these.